Okay, gentlemen, let's go over the study guide. If you didn't see my most recent email, I am editing the test, so we're not gonna do any two-column proofs. We're gonna take more time on two-column proofs next week, and have some sort of a smaller quiz or a test on next Friday. That's still to be determined. So for now, let's just worry about what we have here. So when I say define even and odd numbers, remember this is going to be our 2k and our 2k plus 1, where k is an integer. So I'm going to write this in two separate ways, where k exists in the integers. These two things, they mean the same exact thing. This E basically means exists, and this double Z means integer. You could use either one. You could use them interchangeably. It doesn't matter to me. Just remember that this is this whole thing is the full definition. You need 1,000,000%, you need to define what k is. If you don't define what k is, this could be 2 times an irrational number or something like that, or 2 times an apple, or 2 times, I don't know, my left leg. You need to define what k is, or else it doesn't make any sense in terms of math. Okay? Excuse me. So now when we're writing the symbol and defining the following, so this is what this is going to be. Natural. It's going to look something along the lines of this. And this is counting numbers greater than 0. So this is like starting 1, 2, 3, on and on and on. Okay? Irrational numbers, this is noted by P, and this is a number that cannot be made by dividing two integers. So this is an example of irrational numbers. Pi. E is another one. This is something, this is called Euler's number, or Euler's. I can't actually remember how to say it. It's like 2.7 something along those lines. This has stuff to do with like logarithms and all sorts of fun things. So those are two examples of that. A whole number. This is a W. I believe it's like this. So it's like on the left, or I don't know, on the downstrokes it's just like a double letter. So this is a counting. I'm just going to copy this since it's pretty close. So it's a counting number greater than or equal to 0. So we're going to have this 0. Oops. Beautiful. So whole numbers do include zeros. An integer is the double Z, as we've been doing. And an integer is counting numbers from negative infinity to infinity. A complex number is a C, and it has a little vertical line here. So this is a number that is expressed in terms of the square root of a negative number. So let's just go negative x. This also, as we very briefly talk about, I is what's called an imaginary number, and I is just equal to the square root of -1. So real number is it's like a number. I shouldn't say it like that, excuse me. Basically all a real number is, it means it's not imaginary. What just happened? That was so weird. Whatever. An irrational number is, it's a Q, and it has that line. So this is, so it's irrational, but it's something that can be made by dividing two integers. So some examples of that, like 23/2, 1/3. I don't know, 12/6, stuff like this. So it can be written as the division of two integers. I think I mentioned this in class, but I will not make you write the whole definition. Okay, it will be some form of matching, this, that, something like that, with the terms and the letters and this stuff. So not too difficult. So now I'm going to go over some proofs. This might take a while, it'll be a long portion of the video, if not the whole entire thing pretty much. So when we're doing a paragraph proof, remember we're going to start with saying that it's a proof. We have to have this proof label up top, and then what we want to do is have our intro. So we're going to introduce our terms. So let's say let E be an even number such that 2k, E is equal to 2k, where k is an integer. This is going to be our intro. So this is the intro. The body will follow. So now, we want even plus even is equal to even. So that's 2k plus 2k is equal to 2k. What we do now is we can do one of two things. We could factor out, well, let's write our options off to the side. So if we have 2k plus 2k, we could factor out the 2. We can go to 4k, and this then goes to your 2 times 2k. And what else can we do? Oh, we could do that. Yes, that's correct. So we could also do a situation where we call these parts M, or we can call them K. So I'm going to choose to do this one for this example, and I'll name it M. I'm going to try to do a little bit of everything, just so that you get a flavor and taste, and you could see what you like. So this is gonna be 2K. 2K, where m is equal to 2K. So then we have 2m equals 2K. Now we can define what m is. M exists in the integers because an integer times an integer is equal to an integer. Now, because m and k are integers, m is equal to k. So what we can do now is just substitute back in. So we can get 2k is equal to 2k. So because m is equal to k, we could take this m and plug it in for k. Or vice versa, we could take the k and plug it in for m. So now we got 2k is equal to 2k. We got what we wanted. We got an even number is equal to an even number. So we can wrap it up. So say anything along the lines of, since we achieved 2k is equal to 2k, so since we showed that 2k is equal to 2k, this proves e plus e is equal to e. Okay? That finishes our proof off. So this is going to be pretty much the whole thing. I'll clean it up a teeny bit. Once again, this is our body all the way down to here. This is our body. And this is our conclusion. So this is what I expect. Your wording might be slightly different, and that's fine as long as you have the main elements, the main math. The wording is somewhat trivial as long as you can convey your thoughts. So the next one I'm going to do is a one where we're multiplying. So we're going to do even times odd is equal to an even number. So proof is how we are going to start. So let e be an even number such that e is equal to 2k. I'm just going to copy this because the odd is pretty close. Let O be an odd number such that so let O be an odd number such that O is equal to 2k plus 1. And we're also going to put where k is an integer. Okay. Now what we're going to do is do our math portion. So we could have now we have e times O is equal to e, or 2k times 2k plus 1 is equal to 2k. Now we can do one of two things here. So one thing that we can do is very simple. We can say that because this is an odd number, correct? And we know that odd numbers are integers. We could just name this 2k plus 1 as an integer. So we could do this in two separate ways. So let's do it this way first. You could say where 2k plus 1 is an integer So we can, basically what we can do is, since it's an integer, 2k plus 1, 2k plus 1 is equal to k. So we could just say thus 2k plus 1 is equal to k, because they're both integers, and that's why we can do that. So I'm trying to give you a little flavor of everything. This time I did it sort of exhaustively up top here. This way is going to be a quicker one. So now we're going to have 2k times k, where, or actually let's just write this as 2k squared, where k squared is an integer, thus k squared is equal to k. So now we have 2k is equal to 2k. So this is a super quick way to do it. There's other ways you could do it. We could go through and distribute. So we'll have 4k squared plus 2k. And you could go throughout and do it like this. You could prove that this is an even number and this is an even number, because we have even number plus even number. We're going to get an even number. There's so many different ways that you can do this. So don't get super attached onto one thing. Just try what you like. At this point, we can write our conclusion. So since we have reached 2k is equal to 2k, this proves even times odd is equal to an even number. Okay? So that's all for that. You can do this in a few different ways, like I said, but it would take me 2 hours to go through every single combination that you could do for all of these. So I'm just going to show one, and we could talk about it more in class if you have questions. So prove that an odd number plus an odd number plus an odd number is equal to an odd number. So let's just write out our thoughts on this. Just saying O plus O plus O is equal to O. Instead of going out and writing, 2k plus 1 plus 2k plus... Scratch that, okay? Just think about it more rudimentary, more basic. What is this equal to? Odd number plus odd number. We've already proved this before, and that is an even number, okay? We've already proved that before, so we can use it as a fact. So now we could rewrite this equation as even plus odd is odd. And we've also already proved that even plus odd is equal to odd. And so that is equal to odd, so we're good to go. So maybe this diagram isn't the most... We delete this and just stick with what this says. So even plus... odd plus odd gives you the even number. This odd gets brought down to here. And now even plus odd is equal to odd. And we already know all these things. So now basically all we have to do is write this out in words. So let's start with black. So proof. How should we start? I'm going to say we wish to prove. No, let's restart this. Let's say let's O be an odd number. We wish to prove O plus O plus O is equal to O. So now on our body portion, we've introduced our variables. O, we don't even have to define it, just based on what we are going to do. So I'm going to say now, or actually I'm going to say note that O
plus O is equal to even. So we can rewrite O plus O plus O is equal to whatever as even plus O. Now, note that O plus E, let's write this the other way around. E plus O is equal to an odd number. So, E plus O is equal to O. So now we could say we have reached that O plus O plus O is equal to O. Thus proving an odd plus odd plus odd is equal to odd. No. All right. So you could do this exhaustively, or you could do it like I just did. I suggest you do it like this. It just makes more sense. It's slightly easier. It's way faster. Less confusing. You don't have to do any factoring crap. Yeah. So, like I said, we're not doing this. We're not doing this. We're not doing this. So, we proved, I showed you how to do O times E is equal to, whatever it's equal to. What did we say? Even? Yes, even. So these two proofs are very, very, very similar. So I'll leave that up to you guys. If you guys have questions, please ask me, but you can do them in almost the exact same fashion. The one thing I will say, if you are doing this, remember that you're going to have 2k plus 1 times 2k plus 1, so you have to FOIL. It's first, outer, inner, last. So you're going to have 4k squared plus 4k plus 1. So you have to use this to go ahead and go through. What else? So this even plus even plus even is essentially you're going to prove it the same way we did this. So remember a few things. I am available Wednesday morning, Wednesday night, all night. So this is until 7-ish. There will be a time around 4 p.m. that I do have to go down to talk about the open house. So somewhere around there, I will have to leave. But then Thursday morning, and then I am most of the time available first period, fifth period. You can come in seventh period, and you can come in ninth period. Just get a pass from your study hall, or if you got fifth period lunch, just come on up and we'll talk. I do usually run to the restroom, and I do eat my lunch there. So, if I'm not there, you can just hang out or wait for me or come find me. All right. Anyway, do your best. Try to prove these ones. Don't just stop here. Take a look at these. Some of these proofs are going to be showing up exactly on the test as they are on this study guide. So don't just try to memorize them as well. Try to actually understand them. It'll be way more beneficial for you. Anyway, enough rambling. Go ahead. Have a good night. We'll talk tomorrow on Wednesday about proofs and stuff. And if you got questions, write them down so you know exactly how you want your questions phrased and all that things. So,